All right. Good morning, guys. We're about to start as soon as the bell rings.
Hello. Hello. Students.
You guys ready to learn?
There's always one.
Are you combat ready?
I am.
Wait, who's in there?
Sierra and
Hey, bro, I'm combat ready.
Sierra new.
Sierra, and your name came up as my name.
Hi, Sierra.
Can you tell her that Josie says hi?
Josie says hi, Sierra.
Yeah, I can hear.
Did you hear me scream?
Ah,
Sierra, we missed you.
Come back.
I'm coming back next week. Yes, I am.
Mom is yelling, no, she's not. Somebody close the door.
That was my stepdad, not my mom. What?
Sorry.
No, you guys said I could go back next week.
So it's Haley and Sierra. All right.
I should have muted that.
All right. Hey, listen up. Did the bell ring or no?
No.
Seems like a long time. Oh, there it is. All right, listen up. So occasionally I make a bigger mistake, and I clearly didn't bring your test home with me to grade. So I didn't get them graded. So normally we'd be going over the test corrections, but we're gonna move on. I'll have it graded at least by. I should get it done by tomorrow, but just in case I don't, certainly Wednesday would be the last day. So I graded at least the first, I don't know, 2 pages of it. I saw people like you got 100, and I saw people like okay, we may be looking at a retest or something like that. I'll show you. So we are going to move on to chapter 2.
Nope.
All right. We are ready to start. So let's see. Looking at the calendar, quiet please. Look at the calendar. We have nothing but classes, 3-day weekend. So we'll have a quiz middle of next week. Middle of next week. This is the chapter that I'm not going to say that chapter 2 is, oh boy, does it get hard? It doesn't. So it doesn't. For those of you that had solid pre-algebra skills from last year, you'll be fine with this chapter. It's the 3rd chapter where it gets challenging. For those of you that found chapter 1 challenging, well, chapter 2 is certainly going to be challenging as well. So for those of you that are struggling right now, I need 2 things. One, Joseph, stop. I need 2 things. One, a couple of you already are coming to see me for tutoring. That's fine. But when I walk into your student advisement teacher and I say, all right, who needs help? And you know that you're struggling with math, do me a favor. Just call me over. I will give you the teacher book and allow you to check your answers. You might not be struggling, or you might really be struggling, but I need you to take an active role in your, learning process. And for that, that means this. I'm not going to let a single day go by where I don't understand what was going on. If you sit in class, you're like, I got this, then you'll be fine. But if you're sitting in class and you know already that you're struggling with the material, and then student advisement comes around and you're not doing anything, right? I know that Miss Evans doesn't let you get away with murder this year. Last year was kind of different. But this year she's cranked down hard. You got a good environment for study. Use that time wisely. And then when I come in, I'm not saying everyone has to, but if you need help, that's the time. At a minimum, If you want confirmation that you're doing things rightly, just ask me, Kate, can I check my answers against the teacher's manual where all the answers are? I'm going to say yes every time, right? I'm not keeping the answers a secret until the next day and reveal them to you, right? That's kind of weak teaching method there. So please let me assist you, but I can't get into your head until the next day. And I see that, wow, they missed everything, right? Let's try to, make some attack of the problem before it's the next day and we're grading it and we find out we got everything wrong. By the way, the homework was been on the board. You been copying it down?
No.
All right, you can do this without making noise, please. So my claim is that we don't start the real challenging stuff for a while. And that's pretty much the answer. I think that many of you, if you're looking at what I just handed you, you're looking at it like I know how to do this right now. Some of you maybe not, but most of you should be able to look at what I just handed you and say, I already know how to do this. This is pre-algebra, and you are right. This is pre-algebra. This is not Algebra 1. So today is a review of skills that you should have mastered last year in pre-algebra. We will use today's stuff throughout the entire year. Just like we use addition and subtraction, we don't even think about it to get to an answer. The stuff that we're doing today, you don't think about it. You just write the answer. It's that basic level of understanding. Here we go. So these are called basic assumptions. Basic assumptions. We're talking about something in math called properties. Something in math called properties. And I will just say, you're going to get this class, every single math class you take, including into calculus. This is always, usually this is a chapter 1 class. These things called basic properties. Right now in geometry, I'm doing basic properties. Some background information, all right? We're going to be talking today about what are called the real numbers. And for some of you, you still don't realize that there are things other than real numbers. Not this year, but next year, and certainly into Algebra 2 and higher, we explore things that are not real numbers. They're called imaginary numbers. Your calculator right now is set up to do only real numbers. I can press a button on your calculator where it can start doing math with what are called, right, they're called imaginary numbers.
How can you have imaginary numbers?
Well, that's the thing that you will wrap your head around next year. All right, but real numbers, these are basically all the numbers you know. They have some breakdown of what type of numbers these are. We think about these as bags of numbers, right? The two large bags that make up the real numbers are called the rational numbers, right? And what are called the irrational numbers. The rational numbers are any number that can be written as a fraction. We use the word ratio for fraction, a fancy word for fraction. So any number that you can write as a fraction, like 5, 10 over 2, 5 over 1, 20 over 4, those are called rational numbers. So those include the decimal numbers. Those include your fractions. Yes? Not yet. We're not writing down anything yet. Irrational numbers are those weird ones. These are the numbers that you cannot write as a fraction. The square root of 2, right, cannot be written as a fraction. Pi is an irrational number. Those are, at least up to this year, probably the 2 irrational numbers you dealt with. Turns out there's an infinite number of irrational numbers. And from geometry and onward, a little bit this year, we will be dealing with irrational numbers as well, too. We'll be doing lots of math with irrational numbers. Primarily, the numbers that you deal with in Algebra 1 are rational numbers. These rational numbers we break down are what are called the fractions and your decimals and your integers. Your integers are, remember, the whole numbers, they're opposites from 0. But your fractions and your decimals, right? Fractions and your decimals are rational. And we got to make one caveat to that, right? A decimal number that goes on forever and never repeats, technically it's a decimal number. However, we term it an irrational number. So that's the one small caveat. So, not yet. So that's just your background information. Today we're going to be talking about properties of the real numbers. Now, since you don't know what an imaginary number is, you don't need to worry about that yet. But these are properties that apply to all real numbers. All right. So, some properties about these numbers, or some facts. The first one is the weirdest one, right? And you have not been exposed to this. It's a fairly easy concept. It's just, it has a weird name to it. So you watch the board and you got to follow along. So here we go. So here is a poorly drawn bag, right? Very poorly drawn bag.
It's like a speech bubble.
So it's got an opening right here that's closed because we're not going to let any numbers come out of the bag. So inside my bag, I'm going to put all the real numbers. So I got my whole numbers. I've got my decimal numbers. I got my integers, my positive and negative numbers. More whole numbers. I've got my irrational numbers. The square root of 8 is irrational. These are all the real numbers. All of these make that up, right? Inside there, I just showed you a few, but all the numbers are there, right? We don't allow any number to get out of the bag. So we gotta close the bag. So the bag is closed, right? The first thing, and this is the rule, and this is the first thing you will write down, is the first property that deals with these numbers, and it's the fact that the bag is closed. No number can escape because you're a real number, right? If you're a real number, you must be in the bag called real numbers. So guess what we call the first property? The fact that the bag's closed.
Real numbers.
Close properties.
We literally call it the closure property, right? So when we close the bag, and the bag's full of real numbers, property number 1, write this down, box 1, is called the closure property. If you can picture that thing, that these real numbers, all of them, are in a bag and it's closed, you got the basic idea. And the basic idea is this. For any 2 of those real numbers, take 2 of them. If you add 2 of those numbers, what must you get?
Another real number?
Another real number. You don't get a chance of getting out of the bag. That's why it's literally called the closure property.
What's the point of
Then if you add an A and a B and a real number, you get another real number.
what's the point of that?
Well, I mean, that's the whole purpose of this thing called the closure property. The bag is, I made that part up, right? But the closure property, and it's a good metaphor, it explains it. Is that if you take 2 of the numbers in the bag and you add them, you get another number in the bag. Right? That won't be the case when we deal with imaginary numbers. So for instance, if I pick 3 and 1, they're in the bag, right? What's 3 plus 1? Did you get to jump out of your bag? Is 4 out of the bag?
No.
The 4 is inside the bag. That's why it's called the closure property.
Okay.
You add 2 numbers, you stay inside the bag. Does that work if we multiply? Does that work if we subtract?
Yes.
Does that work if we multiply?
Yes.
Does that work if we divide?
Yes.
The closure property works for all of that. If you do any of those operations, the only possible answer, if all the numbers are in the bag, is your answer's inside the bag. That's why it's called the closure property. We can't get out of the bag if you're dealing with real numbers and your abstract multiply divide. Yeah.
How do you know when your number is
So I started off by saying inside the bag are all the numbers that you know exist. Because right now you don't know what an imaginary number is. Right? All right. So you add 2 numbers, you stay inside the bag. That's why it's called the closure property. The closure property also applies to multiplication. It also applies to subtraction, also applies to division. Right. A couple exceptions with division. You can't divide by 0. Further, it says that if you add the product of 2 unique real numbers, you get another number. Right? Notice what I said, 2 unique. Give me 2 numbers, Sophia. 7 plus 2 does not equal 7. If you give me 2 different numbers and I add them, what must I get? I got to get a different number. Now I said 2 unique numbers.
What was 3 and 1?
0 plus 0 is 0, right? But you didn't give me 2 different numbers. You give me 2 different numbers and I add them or I multiply them, I get a third number and it's not the same as the number I started with. 1 plus 1 is 2. Now, 1 doesn't work with multiplication. Okay, I don't get a unique number for multiplication. That's the one caveat to the multiplication. But this doesn't say multiplication, it says the sum. 1 plus 1 is not 1. 0 plus 0, however, is 0. So even some has a caveat to it. But remember, I start off by saying it has to be two unique numbers. 0 plus 0 is not unique. 0 times 0 is not unique. 1 times 1 is the one exception. Okay, so that's property number 1. You will be hearing about the closure property between now and your last math course. Now, if you take higher level math, like if you wanted to do something in mathematics, you'd learn a whole lot more about the closure property. All right, property number 2, you've heard this one before. It's called the commutative property. Right, now we're going to get into properties that we can, and property number 1 is cool and all that. You know, at least at this level in Algebra 1, you don't get to really use it much. But property number 2, we're going to use all the time. In fact, this is how we solve equations, right? Something called the commutative property. Commutative property says for any real number A and B,
Not the same definition.
that A plus B is the same as,
B plus A.
yeah, that's the commutative property. Commutative property says that if you have addition, you can change the order around and it doesn't make a difference. You're like, wait a minute, didn't you literally on the last test, you gave me PEMDAS? Remember, PEMDAS is for where you have a combination of addition, subtraction, multiplication, division. But if all you have is addition, heck yeah, you can, 2 plus 3 is the same as 3 plus 2. You can move the numbers around any order you want as long as you only have addition or multiplication. Okay? A times B is the same as
B times A.
Okay, so we call these two the commutative property. Some books will say this is the commutative property of, and this is the commutative property of. Okay, so they give two names to that. Okay, our book just says it's the commutative property. Next year in geometry, I will call it the commutative property of addition and the commutative property of multiplication. But I guess this year they're like, okay, too much to handle. We'll just call it the commutative property. I think of the commutative property as the word commute. You probably heard, hey, my mom and dad commute to work. That means they move from one location to the next. They commute. If you think about commute as an order, what's the order? It goes A, B this way, and then it goes PA. So I'm at home, I go to work. I'm at work, I go home, right? So for me, I always picture cars moving. That's how I remember commutative property. If the order of the numbers and variables changes, you're commuting them. You're moving them around. Maybe that works for you, maybe it doesn't. Check it out. The order goes 2, 3, and then it changes to, I change the order, right? That's commuting. Okay? The order goes 2, 3, now it's 3, 2. I change the order. Commutative property says you get the same thing as long as you only have addition or you only have multiplication. That's how I identified. I just look at the order. Hey, the order just changed. I'm commuting. We good? Property number 3 is the, for those of you that remember this from previous years, property number 3 is, it always follows the commutative property, is the hugging property.
The
grouping.
And that's called the,
I don't remember.
Grouping property.
it is, and we call it the,
Don't remember.
we call it the, oh, by the way, one quick note. The commutative property does not work for subtraction. Notice 3 minus 2 is not the same as 2 minus 3. 3 minus 2 is, and 2 minus 3 is, doesn't work with either subtraction or division. 8 divided by 2 is not the same as 2 divided by 8. Hey, that's 4, and that's 1/4, or 0.25. Okay, so no subtraction, no addition for commutative property. No subtraction, no division for commutative property. All right, back to the hugging thing. Property number 3, I call it the hugging property. It's called the associative property. When you associate with someone, right? So this is the associative property. We get 3 letters now. Notice, what am I associating over here? What's being hugged?
A plus B.
A and B are being squeezed together like you're friends now, whether you like it or not. Right? A plus B, do that first, and then add C is the same as, well, we can squeeze B and C together and make them hug. And then add A to it. Notice there's no subtraction, there's no multiplication, there's no division. If all you have is addition, just addition, then you can associate whatever you want. This is called the associative property of addition. We also have the associative property of no subtraction, no division, but we do have multiplication. So same thing for multiplication. A times B, n times C is the same as B times C times A. Notice, once again, I have no addition, no subtraction, no division, just multiplication.
So you're just changing the grouping symbols?
I am just changing, notice that I changed the order. It goes A, B, C. It still goes A, B, C.
You just changed the grouping.
I'm just changing what's being associated, the grouping symbols. Exactly. Remember the previous one, the commutative property, I changed the orders of the letters. It went A, B, on the other side it went B, A. Now it still goes A, B, C, but what's being changed is what I'm associating. Now I don't mean I'm not changing what you do first. Clearly I do A plus B first here, and B plus C first here on the right. But the order, that's how I visually identify the difference between commutative and associative. I remember sitting in your position, umpteen years ago, and not being able to tell the difference. I used to think that, if I see parentheses, it must be associative. That's not how it works. What works is the fact that I can tell the difference of the order. Read it, Kaylee. A, B, C. What's it say over here? Did the order change? Right. If the order doesn't change, what's changing is the parentheses. That's the associative. Just because you see parentheses doesn't mean it's associative. Typically it does, but you can have the commutative property with parentheses. Okay. Remember, hugs, right? I'm associating these two, and these two are off by their own. Okay. So that's how I visually identify. If the only thing that's changing is not the order 2, 3, 1, 2, 3, 1, but what is changed is what's being parenthesized, right? I just made a new word there. That's the associative property.
Oh, okay.
2, 3, 1, 2, 3, 1. But notice the parentheses around the 2 and the 3. On this side, the 3 and the 1. But this is 6 times 1. This is 3 times 2. We still get the number 6. This is 5 plus 1. This is 4 plus 2. We still get the number 6. And yes, it's a coincidence that both of these add up to 6. I never noticed that until now. Okay, so we got the closure property. It's kind of cool. We will use it later, not this year. But the associative and commutative property we will use. In fact, this is what allows us to do almost all the algebra we do this year, are these two properties. All right, how do you identify them? Well, the order doesn't change, but what changes in parentheses is associative property. Okay, order doesn't change. All right, just like the commutative property, there is no associative property for subtraction or division. There's also not one that combines addition and multiplication. Okay? You have to have strictly addition or strictly multiplication. Let's see, 5 minus 2 is 3, 3 minus 1 is 4. Over here we get 5 minus 1, which is 4. Why did that work? Right, Mr. C needs to come up with better, or did I do bad math? No one's going to catch me on it.
What was it?
I just gave away your free point. What do we get over here on the left side? Okay.
Oh, because it's a subtraction.
Yeah. So on this side you get 2. On this side you get 4. All right. It also doesn't work with division. That's 4 divided by 2, which is 2, and this is gives you 8. Good job. All right. Big deal. So what? This is what allows us to do what we're going to do the rest of this chapter and the next chapter, which is solving equations and adding and subtracting. Okay. So it is a pretty big deal. It's the basic foundation of what allows us to solve equations. So what? I'm going to show you a weak example, and it's always done this way in math books. I find this example pretty weak. I wish they would stress more. This is how you solve equations. Hey, remember, hey, I'm going to subtract 5 from both sides, right? I'm going to regroup things. I'm going to do combine like terms. This is what allows us to do that stuff. So it turns out it's going to help us in two ways, right? The first way is, well, it allows us to do math correctly, right? And that means solving algebra problems. Sometimes, and this is the part that they have in every single math book, and it's like, okay, that's a neat trick. When does this ever happen? Infrequently. Sometimes it allows us to do the math a little bit easier. I'll show you that today. But it will absolutely allow us to simplify. These two right here, we should say allow us to solve equations, but since I haven't talked about that yet, I'm going to leave it as that term. But this one right here allows us to simplify is, well, I guess, you know, the big one. So let's see what that looks like. So here's example number one. This is the rarely used. Sometimes it makes our life a little bit easier. Everybody see the problem? If I asked you 4 years ago to do this problem, what would you do? 4 years ago.
Cry.
Yeah, what would you physically do?
Cry.
No. Tell me, no, I mean literally, what would you do?
42 plus 108.
I would put them all into columns, right? And I would add them up. All right, now that you're in high school, when you look at the numbers, tell me the easier way of doing it.
Group 7 with 43, so it turns to 50.
I like 43 and 7 because I can do that in my head. And I can take that answer and add it to 108. But what allows you to do that? You just move the order around.
The commutative
The commutative property says, well, I can move it around because it's nothing but addition. Okay, this is like 4th grade. You didn't know this trick? Somewhere along you notice that, wait, that's a little bit easier to do. You didn't even know you were doing the commutative property. Yeah, the commutative property allows me to move the 7 next to the 43. And then I want to add the 43 and the 7 first, so I put parentheses around it. Well, that's the associative property, and now I can do it easier. Go ahead, Rylan, in your head.
158.
How did he do that? Because I gave you numbers that are nice and friendly with each other. Will this always happen? Heck no. Hey, here's the other thing. Some students panic at this. Could you just follow PEMDAS and go left to right and still get the same answer?
Yeah.
Absolutely. Yeah. So that would be the third method, right? Fourth method would be ask your smarter brother or sister. But we're going to only stick to the first two methods, Julie. We're going to either go PEMDAS, or in this case, when it's convenient to us, and if the numbers are friendly, we can use commutative and social property. So guess what's going to happen tonight for homework? They are going to give you numbers to either add or multiply that are friendly, meaning that there is a trick. And this is why I don't like this particular one, because how often it does happen in life, right? A 43 and a 7, but infrequently. So don't think that you can always associate two numbers and make your life easier. But today we'll definitely speed the process up. Okay, box 4, here we go. Well, I don't know what 9M is because I don't know what M is. But I do know I have a 7 and a 5, so what could I do? I can add them, but what really allows you to do this is the commutative and the associative property. I'm going to move that 5 next to the 7, put parentheses around the 7 and 5, and I'm going to add those suckers. So therefore the answer is
12 plus 9.
And the reason why we can't go any farther is because I don't know what M is, right? If I knew what M is, I could go farther. This is called, remember from last year pre-algebra, what is this called when you go from here to here? What is this called when I go from here to here? We gave it a, it is simplifying. We called it combining like terms, right? You add your constants with your constants, you add your M's with your M's, your A's with your A's, your X's with your X's, right? This is called combining like terms. What allows us to do it? Commutative and associative property. All right. Once again, this doesn't happen much in real life. Tristan, put calculator on. Look at the board, Tristan, and tell me what are the friendly numbers up there that you would like to add? How much?
52.
I can absolutely add 52 and 25, right? But then I'm stuck with an 8 and a 275. Are there a pairing of numbers up there that make your life easy? Like you could do it in your head. Well, could you add 52 and 8 really easily in your head? Yes. That's what we're doing just for tonight's homework. And anytime that you do see two friendly numbers and you have nothing but addition, remember we couldn't do this if subtraction was involved. But when you have two friendly numbers, group them together. I think many people would argue, Tristan, that 275 and 25 are friendly as well too. So we could do this twice, right? We could have two groupings. We could use the commutative property to move the 25 next to the 275 and the 52 next to the 8. Use the associative property and put parentheses around those two groupings and then add away. Julie, answer? Just for this part. Answer? Answer? Therefore, the answer is you did this in your head. Think about that. You did this in your head. If I would go back to 3rd grade Julie and said, do that, right? She did that in her head. But what allows us to do that is the commutative associative property. Yes, tonight for homework, they're going to give you friendly numbers. No, most of the time you will not have friendly numbers. But tonight you will. All right, we got to do a multiplication one. Box 6. Everybody look at box 6. Chris, can you multiply y times z? No, because I don't know what y or z is. But I do, I got a 7 and a 5. Can you multiply 7 times 5? You can. So once again, I'm going to unassociate. I'm going to commute. I'm going to reassociate, if that made sense, right? I'm going to get rid of the parentheses, because all I have is multiplication. I'm going to reassociate the whole darn thing. I'm going to move the 5 next to the 7. That's commute. And then I'm going to multiply 7 times 5, right? That's the associative property again. All right, now take a deep breath. Do you think I really want you to do all these steps? Why am I showing you all these steps? Why do I have to show you these steps? Remember, this is what allows us to do it. It's the proof of, well, what? You can just move numbers around at your leisure, right? No. The commutative and associative property says if there's only multiplication, we're allowed to do this. So do I expect you to show me all this work? Riley, what do you expect me to show you tonight for homework?
Bare minimum.
Well, tell me what you got to show me.
Just the last part.
Well, you got to write down the problem.
Well,
And for this problem, what do you think is the bare minimum?
probably
I'm okay from here to here,
that's what I was going to do.
right? And then the answer, of course. Lily, what's the answer? We generally tend to write the variables alphabetically, right? It wouldn't be wrong with ZY, but we write them alphabetically. We also write them from numerical. We haven't talked about exponents, but we write them from numerical order greatest to least if there's exponents involved. Okay, who's lost? Pretty standard, right? Nothing too challenging today, right? Don't panic. No, I don't expect you to do all of these steps. But these steps are I don't know, if you were to go to a court of law, they're saying, well, what gave you the legal right? Well, this stuff. But yeah, most of them would jump from here to here to the answer. Okay. Hey, remember, it does help us in 2 ways. One, the last one, absolutely 100%, right? You are going to use this all the time. I mean, almost every single problem that we have in algebra, you will use this. But no, you're not going to be writing these steps. You're just going to be getting to the answer. Okay? So it helps us in 2 ways. One, that's what allowed us to get to the answer, 35YZ. So we're doing the math correctly. So it allows us to simplify, and then if the numbers are friendly, and this is mostly for the addition ones, sometimes it allows us to do the math a little bit easier. Okay, you have 4 of them in front of you, box 7. Do them, please. Box 7. Let's do 7. You have to do all these answers. All right, the first one. Which one are the friendly numbers that you can group together? Circle 2 of them that are friendly. So you're saying add that to that. You can do that in your head, right? Which 2 could you put together really quickly in your head? And any one of the numbers, right? But now I want you to look at the other numbers. You see that these 2? You can do really easy. What's the answer? Yeah, those 2. 2. What's the answer to this? 6. 2 plus 6 is? You've got the answer. Now, I'm just saying, the reason why that worked so easy is because I gave you friendly numbers. Right? You do the rest, right? Group together one of the easy numbers to add or multiply, and then do that. Okay? Anybody need help? Nobody? I'm going to lunch then. You guys can finish up by yourself. Oh, Julie.
I was talking.
Do you mean 6 times?
I don't know when does that.
4 and
6 times 8 is 48.
6 times 8.
6 is maybe not
Because
take
5 times 8 is 50. Yeah.
But how do you not remember that I categorized 6?
I love your outfit, Rosie.
Thank you.
I knew
I got
it was
54 somehow.
For what?
That's what last one. I'll probably do it.
Because 2 times 3 is 6. 6 times 8 is 48.
See how you did that? Wouldn't it be nice if all fractions were like that?
I
No.
occasionally.
Why did you do 2 times 3 to get 5?
More easy.
Why did we like this?
I don't know either.
Like,
But other than
what
that,
even is
yes.
that?
So put a circle under that circle. And get the right answer.
Usually they don't look in.
What's the weirdest thing?
All right, here we go. You got the first one, upper left. What you get?
I got 8.
How often will that happen that the stars align and you get these perfectly friendly?
Not very
Julie was showing me a question with number 8 for homework, and it's these ugly fractions. And it just so happens that when you look at them, there's a common, not a common, not two of them have the same denominator, 2 of them. It happens so infrequently, but when it does, it makes your life a whole lot easier. Yes, 8. All right, go ahead. Next one. Yeah.
So on the way, 6 plus 2x.
6 plus 2x. Now, could I write 2x plus 6 as well? Would that be the same answer? It would be. Piper, you got this one? All right, tell me what to do.
2
Well, that's 10. So what's the answer?
plus 10.
Does it say plus?
So just
10. Okay. So it means 10 times 8. Originally it said 5 times 8 times 2. All right, Chris, you got the last one done?
No, I did.
All right, tell me what to do.
First, I think 2, I believe you can do 8 times. No, that's 8 times 2.
Well, that's 16. Tell me what to do. I'm doing it for you.
8. What do you mean I'm doing it?
So I want you to tell me the steps. That tells me you know what you're doing. I'll just do the math for you. So you said multiply 8 times 2. I said 16. Now what?
16 times 3.
That's 48. Well, so therefore the answer is, and the x, y, and z just poof go away. There we go. All right. So I'm going to go back to this. This goes to everyone. Am I teaching you this year how to multiply? No. So if I ask you to do the work, just tell me what to do. What I'm really just trying to figure out is, do you know what you're doing? I don't even, well, I do care, but I'm saying getting to the 48 is kind of less important than telling me the steps. You tell me the steps, then I know what you're doing, right? We're going to assume that you can multiply 8 times 2 times 3, right? For those of you that still need work on that, well, then we got tutoring for that. But in class, we're just worried about you know what to do. Holy cow, it looks like we're done super early today, right? No, we're not going to eat until how about we just get started on homework? Yes? All right. Hey, e-learners, Sierra, you guys got any questions?
Normally it says John Carter's talking.
E-learners, any questions?
Can I go ask something just about
No, I don't have any questions.
All right, cool. All right, we're going to end it today. If you have anything, send me an email. If not, we'll catch you again, same time, same bat channel, yes?
All right, wait, so are we still using the same exact, like, URL for the Zoom?
Yeah, that will never change, and it will be on every single Microsoft Teams. So if you forget or whatever, you can always find it from either a previous day's work or look to another day's work. So that will never change.
Okay.
Just remember on Friday we meet at a different time.
Okay.
Okay, see you guys tomorrow.
Can I go ask about to make sure I have pretty much.
Everybody wave goodbye.
Bye. Bye.
Farewell, people.
Mr. Bob, it's your job.